And these are the needed coordinates for our ellipse, or to graph the ellipse. But we still have the length of the minor axis, length of major axis, and length of the latus rectum. So we are going to put it here. So length of major axis. This is for the major axis. So the formula we are going to use to find the major axis is 2 times A. So 2A. Substitute A, 2 times the value of A is 2 right here. So 2 times 2 is equals to 4. So that will be 4 units. Then next is length of minor axis. Minor axis. So 2B. That is the formula to find the length of minor axis. So 2, substitute the value of B, which is 1. 2 times 1 is 2 units. And lastly, for our length of latus rectum, we will use the formula of 2b squared over a squared, and then substitute the values 2 times b. So I made a mistake. The formula shall be used to find the length of latus rectum is 2b squared over a and not 2b squared over a squared. Now we're going to substitute it. 2 times 1 squared. 1 is the value of b, and a squared, and for the a is 2. So 1 squared, that is 1 times 2. 2 over 2, that is 1. So 1 unit. Again, so these are the coordinates and the length of major axis, minor axis, and latus rectum for us to graph correctly and properly the ellipse. So I'll be back to show to you the graph of the ellipse for this item. So I'm back with the graphing part. As you can see, I already draw a graph here, which I only focus on the quadrant 3 and actually not focusing on the other quadrants. So in here, these are the coordinates we are going to need to graph the ellipse properly and correctly. So for the center, we have -1, -2. So -1, then comma -2. So it should be right here. And that is our center. For the foci, we have f sub 1, which is -1, -2 minus square root of 3. So we are going to use calculator to actually find the decimal form of -2 minus square root of 3 rather. So that gave us an answer of -3.73. So -1, I'm going to plot it, -1, and then -3.73. I'm just going to align it because it's not that aligned with the number 1. So -1, then -3.73. Assuming that -3.73 is right here, but not actually laying on the point 4 or the 4 or in the 4. So that is our f sub 1. How about f sub 2? So in f sub 2, we have -1, -2 plus square root of 3. Now we're going to just change the sign to positive, And that should give us an answer of negative 0.26. So we're going to plot it, negative 1, comma, negative 0.26. So I'm assuming that negative 0.26 is right here. So that is our negative 0.26. And that will be labeled as f sub 2. So moving on, so for the vertices, we have v sub 1, and our v sub 1 is negative 1, comma, negative 4. Negative 1, and then negative, comma, negative 4. So that should be right here. Is v sub 1. Then for the v sub 2, we have negative 1, comma, 0. So obviously, it's just right here. This v sub 2. So as you can see that the f sub 2 is above the center and f sub 1 is below the center, while v sub 2 is above the f sub 2, while v sub 1 is below the f sub 1. So if we are going to imagine a broken line that will present as the major axis, it should look like this. For us, just to imagine or represent the major axis. It explains here that in major axis, the center, foci, and vertices are on the major axis, or lay on the major axis. Now, for the co-vertices, we have w sub 1, which is negative 2, comma, negative 2. So, negative 2 and negative 2. As you can see, it is aligned with the, or with our center, which is negative 1, comma, negative 2. Then, we're going to label it w sub 1. And then for w sub 2, we have 0, comma, negative 2. Obviously, it is just right here. It's w sub 2. Now, that we complete the coordinates needed to graph the ellipse, I'm just going to draw the minor axis here to represent the explanation for the co-vertices laying on the minor axis as well as the center. So, I'll be back just to draw the ellipse so that it should look an ellipse properly. So, I will be back just to draw the ellipse. So, that's it. This is our graph for the ellipse for activity B, number 7. So, as you can see here, we have the foci, the center, the co-vertices, the latus rectum, and finally, it is in a vertical orientation in quadrant number 3. So, the length of major axis, that is 4 units. The length of minor axis, 2 units. And for the latus rectum, I already draw a line segment in the foci number 1 and the foci number 2. So, I hope you learned something today about ellipse through my answer or through my video presentation. And thank you for listening. Again, I am Juliana A. Molina from Group 6. And thank you.
Hi guys, I'm James Carlibora from 11 Diamond. Today I'm gonna show you how to transform general form ellipse to standard form. So first we need to make the equation binomial. The first step is for getting a binomial, we need a perfect square trinomial. So we're gonna assume or estimate or solve for. Let's first arrange the variables. Where x squared plus 100x plus y squared plus 8y and negative 91. So we can't this is 24. We cannot have coefficient in x squared, so to cancel out we have to factor out, which is 25 x squared, 25 divided by 100, 4, and the third term for creating perfect square trinomial. And for y, y squared plus 8y for the third term, negative 91. For solving for the third term, we have a squared over 2, which is 4 divided by 2, which is 2, and 2 squared, that's our third term, which is 4. 2 times 2 is 4. Now for y, we have 8 squared over 2, we have 4 squared, we have 16. If we put that, we have accomplished the third term, we have to make it on the other side of the equation, which is we have a factor here, so 25 times 4 is 100, and for the y we have 16, only 16 because we have no factors outside the quantity. So let's first solve for the right side of the equation. 100 plus 16 is 116 minus 91, which is 25. So write the equation. Cancel out, to make it 0, we have 2 divided by 25 both sides. Forgot to write it. Cancel out, 0, 1, we have to need a 1 in the right side of the equation, and cancel out, we have 1. So our equation will be like this, and this is a perfect square. We have to make it binomial now, which is x plus 2 squared over 1. So don't need to write the 1 on the, okay, let's write y squared for the other side. No, y plus square root of 16 for square. We have a binomial, wait, over 25. Now we have two binomials. Now to determine, we have a formula. If if a is in the y-intercept, then our graph will be a vertical. Now let's get the center of the equation. Center. Our center is negative 2 for x and negative 4 for y. Now next is the foxy. For getting the foxy, we need to get the c, which is a is always greater than c, or I mean a is always greater than b. Here is 25, and for b we have 1. The c. What is c squared? Transpose 1 becomes negative 25 minus 1, 24. C squared. Square root, we have a perfect square here, which is 4. 2 times 2, let's make the 2 outside. 2 is square root of 6 for the 24. Now for getting the foxy, or for f sub 1, we have negative 2 for the x-intercept, and negative 4, and the c. Our c is 2 square root of 6. For our f sub 2, we have, like in the f sub 1, we have negative 2, negative 4, and the c becomes positive 2 square root of 6. Now for the vertices, v sub 1 and v sub 2, and for the value we have to combine the a in the y-intercept, which is a is square root of 25. We have 5, so let's write it. A negative 2 for negative 2 and negative 4 and negative 5, and for v sub 2 we have negative 2, negative 4 minus negative plus 5. Now for the covertices, we're gonna combine the x-intercept in b. So this w sub 1 for the symbol for covertices, and w sub 2, and for the y, we're gonna combine the x and b for the value of w sub 2. Our b is 1, and negative 2 minus 1, and for y-intercept we have negative 4, and for the w sub 2, vice versa for the b, we have negative 2 plus 1, and for the y, negative 4. Now we have the values of vertices. di pala nakikita. This is the values for the co-vertices. The next one is we have the length of the major axis. Let's write it down. Now for the formula for the major axis, we have 2 multiplied by a. Now let's substitute. Our a is 5, right? Oh yes, 2 multiplied by 5. Our major axis is 10 units, because this is the length. Okay, 10 units. Now for the minor axis, 10 units, because this is the length. Okay, 10 units. Now for the minor axis, length of the minor axis, you have the formula 2 multiplied by b, and our b is 1, so 2 multiplied by 1, we have 2 units. Now for the length of the latus rectum, we have the formula. Let's first write it down. Now our formula is 2b squared over a. Now let's substitute again. 2 multiplied by 1. 2 multiplied by 1 and over 5. So our latus rectum is 2 times 1 squared is equal to, and for the 5, for the denominator 5, we have 2 over 5 units, so 2/5 units. Now we forgot something to solve for the given values of the foci vertices and co-vertices. Now let's solve for it. With the values, we have for the f(1) -4 minus 2 square root of 6. We have here, this is around 0.9, I think 89, 0.89, like that. And for the f(2), we have -4 plus 2 of square root of 6. We have here, I'm sorry, this is 8.89 because negative is negative. For the f(2), we have this is around 0.89. That's it. And 0.89. Okay, and let's write it down, the values. -2 and 8.89. And for the f(2), we'll write the values -2 and 0.89. Now we have the foci, the values of foci. The 0.89 we have here. Okay. Now for the vertices, -4 For v sub 1 and minus 5, we have negative 9. Now the values for the v sub 1, negative 2 minus and negative 9. Now for the v sub 2, we have negative 4 plus 5, that's is equal to 1, positive 1, negative 2 and positive 1. Now for the co-vertices, for the x-intercept and b combination, we have negative 2 minus 1, we have negative 3, right, negative 3, and for the y, which is negative 4, still negative 4, and for the w sub 2, we have negative 1, negative 2 plus 1, so we have negative 1, and for the y-intercept, we have negative 4. That's it. Now let's graph these values to see if our equation is really a vertical orientation. Now for graphing, we have to first know the center. For x, we have here the negative 2 for the left side. Okay, 1, 2, and for the y, we have negative 4, which is downward. 1, 2, 3, 4. Here, let's point it out or graph it. Put some point, and that's it. That's our center. For the next is the Foxy. We have for Foxy, we have f sub 1, negative 2 for the x-intercept, and for the y, we have around the 8.9. So count 1, 2, 3, 4, 5, 6, 7, 8. This around here, 8.89. Let's point it out, the negative 2 in x-intercept. Now for the f sub 2, we have around it the 0 or 1. The x-intercept is negative 2. That's this the y, it's around 1, 0.89. So let's graph it. 0. Now for the vertices, we have v sub 1, which is negative 2 and negative 9. Okay. For the x, negative 2, and for the y, we have downward negative 9. 1, 2, 3, 9. It is around here. Let's point it out. Now let's first label it, because to know what point is being pointed. Okay, this for v sub 1. Now for the v sub 2, we have negative 2 and positive 1 for the y-intercept here. That's here. Okay, point it out. V sub 2. Now next is for the co-vertices, we have negative 3 for the x. 1, 2, 3, and is for the y, it's negative 2, and it's here. It's pointed out. For the w sub 1, and for the w sub 2, we have negative 1 and negative 4, which is here. Now that's for the next step. We have to connect the dots for downwards. I'm bad at connecting dots. Now, we successfully proved that our equation is a vertical, and for using Desmos, as you can see, our graph is perfectly matched. That's all. Thank you for watching. Today, we're going to identify the equation of the directrix of the ellipses of this given problem. So the given is 0, 0 center point in a vertical ellipse. 0, 0 is the center point because there is only x squared plus y squared above, and vertical ellipses because the a squared is below the y squared and b squared is below the x squared. That is why it is vertical ellipse. So the equation of the directrix is x is equals to positive negative a squared over c. Our a squared is positive 81, and to find c, we are going to use its equation. C squared is equals to a squared minus b squared, and it will become c squared is equals to a squared over b squared square root of that. So it will become equals to 81 minus 36 square root is equals to square root 45. Therefore x is equals to positive negative 81 over square root of 45. We will have to rationalize by multiplying the entire equation by square root of 45. So that cancel the square root, so it will become x is equals positive negative, that cancel the square root below. Okay, so 81 square root of 45 over 45. So the final answer is x equals to positive negative 81 square root of 45 over 45. This is our final answer. Thank you.